Okay, so case 3 is when they're at right angles with each other, which means 90 degrees. So we have our box. We have one person pushing with a force of 40 newtons east, but this time the other person is pushing with a force of 30 newtons south. Okay, so we want to find the resultant. To find the resultant, the result of these two acting together, we need to draw them head to tail. So we could pick up this 30 Newton vector and move it over so that it's head to tail right here with the 40. Okay? And that is 100% totally allowed. And if we do that, then the resultant starts where the first one started up here, ends where the last one ends. This will be my resultant. Now the other thing you could have done is you could have picked up the 40 Newton vector and slid it down so that it's down here. So this would now be your 40 newtons going east. And your resultant would start where the first one started and end where the last one ended. You can see that really they're the same line. So it doesn't matter which way you move it. You should also hopefully see that's a right angle triangle, and so you can find the resultant. It's just the hypotenuse. So the resultant squared will be equal to 40 newtons squared plus 30 newtons squared. And no, you don't really have to add this out, write this out, but I am so that I don't lose you. 40 squared is 1600, 30 squared is 900, add them together, it's 2500. Take the square root, it's 50 newtons. If you did it the other way, with the 30 and 40, it's still going to be 50 newtons. But remember, this is a vector, so we need a direction. And we always need to measure our direction with respect to like the x-axis and the y-axis. So like the east, west, north, south, or up, down, right, left. So if I moved the purple, if I moved the 30 and I'm looking at the purple, then the angle I want is this angle in here. And I can find it because I have the opposite and the adjacent. So that would be tan. So I would do tan theta is equal to, opposite is 30, adjacent is 40. So 30 newtons over 40 newtons. So I'd get 0.75, and I would do second function tan on my calculator. And I would get, doing it in my head, 36.87 degrees. Okay, so we know this angle is 36.87 degrees, but if you were to tell me I need to turn at an angle of 36.87 degrees, you'd have to say with respect to what? Like I could be like, okay, 36.87 degrees to the left, to the right. And so we're measuring this angle off the east here. And so the way we write it is with a square bracket, and we say, okay, we're starting east, so we put an E in, okay? And then we turn 36.87 degrees. And which way did we turn? We turned south. And so then we close with a south and close the bracket. And this would be the result of those two vectors acting at right angles. Now, if you did it in the red, you would still get your R to be 50 newtons, but the angle's going to be different. The angle's always where you began, the vector you began with, and the resultant. And so my angle would be here. So now my opposite is going to be 40, and my adjacent's going to be 30. So this time it'll be tan theta is equal to 40 newtons over 30 newtons, which is 1.3 repeating. Take the inverse tan, and that's 53.13 degrees. So it's a different angle. But that's okay, because I'm also measuring off of this time. I was originally going south, and now I'm turning 53.13 degrees. Which way? To the east. And so this answer is also 100% correct. It doesn't matter which one of these you use. Notice that the two angles are complementary. They add up to be 90. And that the only difference is one you're measuring from the east and going south, the other you're measuring from the south and going east. Okay? So when we get to right angles, then this is how we'll add our vectors. That was case 3. There's one more case. Case 4, so case 1 was 0 degrees. They were going in the same direction. Case 2 was 180 degrees. They were going in opposite directions. Case 3 was right angles, 90-degree angles to each other. And case 4 is any other angle. So all the other angles between 0 and 180 go in here. So it might be, here's my box, it might be that I have my 40 Newton force going this way, east, but maybe my other force, my 30 Newton force, maybe is going at an angle in here of like 30 degrees. Okay, so to find the resultant, I need to move my 30 out so it's head to tail. I'm just going to redraw it over here. So here's my 40 newtons east. And when I move my other one head to tail, it's going to be out here. And it's 30 newtons. And this angle is 30 degrees. My resultant still starts where the first one started and ends where the last one ended. So this will be my resultant. And there are 2 ways we can find this. One way is to realize that this 30 Newton angle at 30 Newton vector at an angle is really just a hypotenuse that's probably searching the universe for its legs. It has a leg in the x direction, and it has a leg in the y direction. And we can find it by saying, oh, I have the angle and the hypotenuse, and I want the adjacent side. So I could use cos. So I could say cos of 30 degrees is equal to adjacent x over 30 newtons. So x will be equal to 30 newtons times the cos of 30. And I could do the math. Cos of 30 is 0.866 times 30 newtons, and I'm going to get x is equal to 25.98 newtons. So down here at the bottom, 98 newtons. And then I could find my y, because my y is the opposite side, so I could do sine of 30 is equal to y over 30 newtons. So y is equal to 30 newtons sine of 30. Sine of 30 is 0.5. Y is just equal to 15 newtons. So this side is 15 newtons. Now something really cool happens when we do this. I said a minute ago this hypotenuse is searching the universe for its legs. It might even haunt you at night. At night when you're lying in bed, if you listen closely, you might hear the hypotenuses of the world saying, help me find my legs, help me find my legs. Really, they would do anything to find their legs. And once they find them, they actually disappear. So here's my 40 newtons if I redraw it going east. But now, and if I was on the whiteboard, I would just erase this line out, but I can't do that here. So here at the bottom, I have 25.98 newtons going this way. I have 15 newtons going this way. My hypotenuse is gone because its legs have taken its place. And here is my resultant, and lo and behold, I have a right angle. And I know what to do when I have a right angle. I do the Pythagorean theorem, and I use tan to get this side. Okay, so on Monday in class, I'll do this one again in person, and I'll show you another way to do it because there's 2 roots. But it's really important to know how to do these components as we move into physics. And this was why I made you practice trig. Not sine law and cosine law, trig. So we can get the legs of our right angle triangles, okay, easily. All right, so your homework for over the weekend is work on your assignment. On Monday, I will give you the sheets of notes, and we will come back to finish this, and we'll finally get started in real physics. Okay, have a great storm day. Have a great weekend. See you Monday. Work on your assignment, please. And now the conversion sheet, which was due on Friday, today, will also be due on Monday. Okay, have a good one.